Hi dears, today we can see CSIR NET Max from linear algebra. First question, which of the following subsets of R power 4 is a basis of R4? So 4 bases are given. We have to check whether B1, B2 are the basis or B3 is basis or not, such a way. So here it is given, if S is linearly independent and the dimension of B is N, then we can say that S is a basis of B. So here dimension of B is N. Here the dimension of B, that is equal to 4, right? 1, 2, 3, 4. The dimension is 4, so that it is okay. And second, we have to check whether that subset is linearly independent or not. So that we have to see that. If it is linearly independent, then we can say that the subset is a basis of B. So similarly, it is given the next result. If the dimension of S is less than the dimension of V, then it cannot be the basis, but it will be extended to the linearly independent. If it is linearly independent, then it will be extended to the basis. So first I am taking the basis here. The first one, 1, 0, 0, 1, 1, 0, 0, this value. So for linearly independent, we know that A V1 plus B V2 plus C V3 plus D V4 is equal to 0 with all C's are, that is A, B, C, D or 0. If it's so, that is linearly independent. So A into V1 plus B into V2 plus C into V3 plus D into the equal to 0. So here A, here plus B plus C plus D, and take the first element alone, which is equal to 0. Now take the second element. Here it is 0. Here B plus C plus D equal to 0. Now took the third element. Here it is 0, 0. Here C plus D equal to 0. And here take the last element. 0, 0, 0. So the last element D equal to 0. So substituting here, D equal to 0 gives C equal to 0, again D equal to 0 and A equal to 0. So if all C's, that is A, B, C, D are 0, then we can say the corresponding basis is linearly independent. Let's check the second one. This is the second one. The same way, A plus here B plus C plus D equal to 0. Then here there is no second element. Here 2B plus 2C plus 2D equal to 0. Third element is not here. Third element here not here. Here 3Z plus 3D equal to 0. And similarly 4D equal to 0. So that D equal to 0 gives C equal to 0, B equal to 0, A equal to 0. So B2 is linearly independent. Similarly, we have to see B3. So A, 2A, 0, 0, 0, 0, B, 2C, C, 0, 0, minus 5D, 5D, 0, 0. Accordingly, if you do, you will get these values, okay? D equal to 0. Here there is no B value. So do the elimination method. There you can see that A plus C equal to 0 gives A equal to minus C, where this C belongs to the real number. So it belongs to more infinite value. It is not equal to 0. According to linearly independent, all this A, B, C, D are all equal to 0. But here B is equal to 0. This is not equal to 0. It carries more value. So B3 is not linearly independent. So according to this question, B1 and B2 are the basis, but not B3. So the first one is right. Let's see the next question. Second question, let V be the vector space of polynomials in two variables over real. What is the dimension of V of all polynomials having degree at most L? Okay, 2023 question. What is the dimension of all polynomials having degree at most L? And here you can see this is of two variables. So for this type of problem, dimension of all polynomials is equal to n plus variable C variable, combination C variable. That is n. Here you can see that degree at most L. So L plus how many variables are here? Two variables. C variables is 2. So combination way L plus 2 into L plus 1 divided by 2. So option D is the right option. Next question. Let A is equal to 1, 0, 2, 1, minus 2, 0, 0, 0, minus 3. I be the 3 by 3 identity matrix. If 6A inverse is equal to A square plus BA plus CI for ABC belongs to R, then ABC equals. So write the given one. Now multiply A on both sides so that this becomes A inverse into A is identity, then A cube, then A square into I into A. So that bring all to the one side. divided by A, you will get B by A square plus C by A minus B by A is equal to 0. This looks the characteristic equation, lambda cube minus trace of A square, then plus minor value of A minus determinant A is equal to 0. So here you can see that A value is equal to 1. Okay. So A is equal to 1. Then trace is equal to, here you can see that minus B by A, because here minus trace is equal to, right? So the trace is equal to minus B by A. So trace from this matrix, sum of the diagonal value 1 minus 2 minus 3 is equal to minus B divided by A value is 1, so that we can see B equal to 4. So from this A equal to 1, B equal to 4, option D is there. So automatically you can write that option D is the correct one. Let's see the next question. Question number 4. What is the rank of the following matrix? Just like the normal one, bring this to the row echelon form. So here you can see that by row echelon form 1 minus 1 0, 2 minus 1, 2 minus 1, 2 minus 1, 2 minus 1. Similarly 1 minus 1, 2 minus 1, 3 minus 1, 3 minus 1, 3 minus 1, such a way. Again you have to reduce to the lower echelon form. So the number of zeros, the preceding will be greater here. Okay, such a way if you are doing, you can understand that this is the rank of, that is number of non-zero rows is 5. So rank of the matrix is equal to 5. Next question. Let AB be n by n matrix such that BA plus B square equal to I minus BA square, where I is the n by n identity matrix. Which of the following are true? First write the given one. Now BA plus B square plus BA square is equal to I. Take B outside. So A plus B plus A square equal to I. Now take the determinant, because the question contains non-singular. So we have to take the determinant on both sides. So determinant B, determinant A plus B plus A square equal to determinant I. Identity matrix is equal to 1, which is not equal to 0. This gives determinant B not equal to 0. That means B is non-singular. So according to this question, B is the right answer. Thank you.